right, we're in the second half of 3.9, antiderivatives, and we're going to look at situations where we've got a function, the derivative of a function. We want to find the original function, but this time we have an extra piece of information, which is we know the value of the function itself for a single input, or in the ones we'll look at in a minute, for a couple different inputs. These are sometimes called initial value problems because we know how the thing's changing, right? The derivative is how something is changing. So we can tell what's going on with the function, and we can tell everything about it if we know where things started. It doesn't actually have to be an initial value. F of 0 would be. We still call this initial value. So step one is what we covered last time. We're just going to find the antiderivative of the derivative, which will be the function itself. T will give us t squared over 2. And this is t to the negative 3 power. So it'll end up being t to the negative 2 power divided by negative 2. So we're going to end up with negative instead of positive and 2t squared in the bottom there. Plus c. Now if we put a 1 into this function, we get 1/2 minus 1/2 plus c, and we know that has to equal 0. And then we solve that, that has to equal 6. We put a 1 into the function, we get a 6 out. We get 1/2 minus 1/2 plus c equals 6. Really easy to solve that one. We know that our c is going to be 6, and from my point of view, there's no need to rewrite that whole thing, especially when the number looks kind of like a c anyway. We can just erase the c and replace it with the constant. Try another one. F of x, 3x squared. Increase the exponent to x cubed, divide by 3, so we'll get x cubed, plus that'll be x squared. That'll be 5x plus c. And we know if we put a 2 into that function, we're going to get a 20 out. So 2 cubed is 8, plus 2 squared is 4, plus 5 times 2 is 10, plus c has to equal 20. 8 plus 4 is 12, plus 10 is 22. So c here has to be negative 2. And as I said before, you're welcome to just cross that out, plug in a negative 2, and call that good. What? You want to do a second derivative example? Okay, I would have stopped with single derivative, but since you're going to ask, let's do second derivative. And to put these in context of what they kind of represent, if we know the derivative of a function, and we're talking about a particle in motion or a car in motion or whatever, then we know how fast that thing is going at any moment in time. If we know how fast it's going at any moment in time, we should be able to figure out where it is at any moment in time. That's really what we're doing with these initial value problems. F of 0 is 8, and f of 1 is equal to 5. Okay, so we've got the velocity of our car at any moment in time, and we know where it is when it started and where it is after 1 second, and using that information, we can figure out where it is all of the time. Our first derivative here, right, we're starting with second derivative. Our first derivative is going to be x to the 4th divided by 4, so that'll be 5x to the 4th, plus that'll be x to the 3rd. Divide that by 3, we get 4, plus 4x, plus c. Then our function itself, right, we started knowing where what the acceleration is. We found from that the velocity. Now we're looking at position. That's just going to give us x to the 5th. That's going to give us x to the 4th. That's going to give us 2x squared. That's going to give us cx. And then, because there might have been a constant on this one, we can use D, we can use C1 and C2, you can use C and K, it doesn't matter. Any letters will do, because they're not going to appear in your final answer anyway. Now here we know that f of 0 is 8. Well, that's going to be 0 plus 0 plus 0 plus 0 plus D equals 8. So we know that D is going to be 8. Our initial value problem is always easier when we actually do have f of 0 to start with, especially when we're dealing with polynomials for exactly this reason. Put a 0 in and all you're left with is the constant. If we put a 1 in here, we get 1 to the 5th plus 1 to the 4th plus 2, right, we're putting it right in here, plus c times 1 plus 8 equals 5. 1 plus 1 plus 2 plus 8 is 10. Double check. No, that's not right. 1 plus 1 plus 2 plus 8 is 12. So that c has to be minus 7 for this to work out. So our original function, x to the 5th plus x to the 4th plus 2x squared minus 7x plus 8. I think that's probably enough for you to catch on to this idea. Let me know if you have any problems.